Good morning, Abyss. Here we are at BC Calculus.
Mr. Olmanson, I harassed Olivia. Please write me up.
Okay. I don't think Mr. Olmanson will watch us.
He should.
He should.
Can I go tell him to?
I think
No.
Why not?
Did we do number 2?
He's the greatest
We did number 2 in what we did for
He's
like
literally
all-
like
yeah.
my favorite
We
person.
did like all of it in one go.
In one go?
Yeah.
And what did I come up for theta?
He's new.
Theta for
But he's gonna be the
Number 2.
you had pi over 2 and 3 pi over 2.
And 3 pi over 2.
Yeah.
And, oh, and so we get 1 comma pi over 2. And we get 1 comma 3 pi over 2. And then we said we had this intersection right here, correct? And did we say, we said 1 comma pi, or we said negative 1 comma pi, or something like that?
Yeah.
Or a negative 1 comma 0? Right?
Yeah.
All right. And so actually there are 3 intersection points.
So are those 2 on the right? Those are the same points, right?
These right here?
Yeah.
Yes, they are the
Yeah, we
same.
definitely talked about that yesterday. Mr. Kruger, I seem to have misplaced my pen.
Would you like a pen?
Do you have a pilot G2.38?
I have a purple
I
pen.
think I actually do.
I
I do. Oh,
It's
Wait, I might have a colored one. I might have a colored. I do have colored ones as well.
Alrighty, Jaden,
I'm impressed because my pen ran out of it.
Well, you obviously have
Yeah, no.
you ready?
I'm ready.
Okay, walk me through how to figure out these intersections.
Number 3?
Number 6, example 6.
Oh. Okay, so you put the r's equal together, or equal to each other, so it'll be 2 times 3 cosine theta equals cosine theta.
Okay, wait, I have a question about the other one.
Yep,
So wait, you said there's 3 intersection points, so then why is the question, why is there only
that's a
2?
mistake.
Okay.
Wait a second here.
Wait, so why is this
I'm
actually not an
just confused. So we're just crossing that one out. Alright.
Okay, Jaden, keep going.
Okay, and then you get the left side equal to 0, or I guess you could do the right side either way. So that would be 2 equals 4 cosine. And then you divide by 2. Oh, what are you-
Divide by 4.
Divide by 4, yeah.
Okay,
And then theta equals the inverse cosine of 1/2.
mm-hmm.
I have 3.
Pi over 3, I heard.
Oh,
And what other spot?
and then it would be
It's going to be in the first, this is in the first, and in the 4th quadrant.
5
5 over 3.
3.
So my points are
I know.
1/2 comma pi over 3, 1/2 5 pi over 3. So if we take a look at the graph,
Wait,
why don't you guys graph it and tell me what it looks like?
so do you just plug in those things to get the 1/2?
Correct. I believe our cosine theta looks like this.
Bear lightning's in my car yesterday, just in case. Yesterday.
Can you move it up a little bit, please?
So,
And over 2.
so is this one
Yeah.
here or ours?
You just go to mode. And change.
Two minus 3 equals theta over.
That's probably why
What does this graph look like?
A giant intersection.
Of a hole.
It's got a loop inside a loop or not?
It's like a loop, but the loop's on the other side.
Loop goes like this?
Yeah.
Okay, like this. Something like that?
Yeah. I mean, the
Sure.
circle is supposed to be way smaller.
So here are the 2 points that we came up with the intersection. They're not drawn very well. So they must also intersect where, do you think?
0.
Yeah, at the pole, right? And you can see that when cosine is pi over 2 or pi over 3, excuse me, pi over 2 or 3 pi over 2, you're going to, this one is going to hit the pole. And this one can also equal 0, or it can be 0, when I solve this equation. And the cosine inverse of 2/3 is going to be the theta in which that is. So 0, 0 is an intersection, which is the pole. And all you have to show there is that both of them are possible to cross at that point.
Wait, I'm
Okay?
confused. So then you set them separately equal to 0?
Right, yep. Is it possible for r to be 0? Yeah, it is.
Yeah.
At two different thetas, but it does mean that they cross, not at the same theta, but at a particular theta. Does that make sense? Okay,
Yep.
all right. Can I go on to the next one? All right. So we are figuring out the common area. And the common area, did I shade this one at all last time or not?
No.
So this is the common area. And this equation, if I let sine be 0 here, r is going to be 5. So this equation right here, if you notice 0, 5 is this point. So this equation right here is 5 minus the sine of, or excuse me, 5 minus 3 times the sine of theta. Likewise, if I let cosine equal pi over 2, which is right here, r would be 5. So that's this particular equation. Just to identify which is which. So I give you some helpful hints here to determine that. First thing you want to do is figure out the intersection points, this point and this point. And so we will do that, and we'll do it the same way that Jaden had told us. 5 minus 3 sine theta equals 5 minus 3 cosine theta. And so I get negative 3 sine theta equals negative 3 cosine theta. And I get the sine of theta over the cosine of theta equal to 1. And I always write this as the tangent of theta equal to 1. So I'll slide this a little bit so you can see that. So theta is equal to what? Pi over 4 and 5 pi over 4. I already shaded in the area that I'm trying to find, and I'm going to determine symmetry. And if you notice, there's symmetry right along this line right here. It takes that area and cuts it in half. And so I'm going to write my integral. And my integral, if you recall, is 1/2 from some type of angle measurement that I call alpha to another angle measurement that I call beta. And it's going to be r theta, that function, squared d theta. But since I can integrate just one of these. I can multiply it by 2 to get the entire area. Would you agree? So what I'm going to do is I'm going to multiply by 2. So I'm going to have 2 times 1/2. And I'm going to integrate from pi over 4 to 5 pi over 4. And so what I'm looking at, and I'm going to come back to this, is I'm looking at very skinny sectors that are generating from that pole. They're going to start over here and they're going to move in this manner. And these are just a few of the infinite number of sectors there are. So my question to you is, what am I squaring? What is the length of this R? Right. 5 minus 3 sine of theta squared d theta. If I would have done the whole thing, I would have had 2 separate integrals where I would have went from pi over 4 to 5 pi over 4, and then 5 pi over 4 to 9 pi over 4, and I would have a different R because it would be this inner loop. It would be this R right here. Does that make sense?
So you don't have to do another integral with a different?
No, because I know, because I have symmetry, I know that this half is equal to this half. So if I just figure out this half and double it, I'll have included that half.
This may be a dumb question, but how do you know that's symmetrical? Like, I can see that it looks symmetrical, but how you're not always supposed to...
Yeah, I would say if I look at the equations are identical except for the difference between sine and cosine. And so the difference between sine and cosine is only a rotation of 90 degrees because they're co-functions. And so these are the same function, just rotated 90 degrees about the pole. I don't know if that's a good enough explanation.
No, I get it.
I think most of the time, especially when dealing with polar coordinates, and everything seems to be kind of based on this rotation, the circular type motion, that I think symmetry is apparent. And I do use the graph a lot, to be honest with you. Okay? All right.
Why would you choose to do the 5 minus 3 sine whatever as opposed to the minus cosine?
I could use the other one, but then I would have to go from 5 pi over 4 to 7 pi over 4. That's the only difference. I mean, I don't know if there's one that has more of an advantage or the other. You're saying, what's the advantage over the top half over the bottom half? I guess because pi over 4 is smaller than 5 pi over 4, to be honest with you. That's the only difference. Okay? So I'm going to give myself a little bit more room, and I'm going to write it on here. So now I'm down to this. And I have pi over 4. And I have 5 pi over 4, and I have 5 minus 3 times the sine of theta squared d theta. And when I expand it, it's going to look like this. 25 minus 30 sine of theta plus 9 sine of theta squared d theta. And so this is the one where we're going to use this 1 minus the cosine of 2 theta. This identity, based on what we saw yesterday, we use a lot. So I'm going to integrate this right away, and I'm going to get 25 theta. Is that okay? I'm going to integrate this right away also, and the antiderivative of sine is negative cosine, so I'm going to get plus 30 cosine of theta. Are you okay with that? That I just do those right away so I can concentrate on this? So I'm going to just look at this, and I'm just going to figure out the antiderivative. I'm going to write this as 1/2 minus 1/2 cosine of 2 theta d theta. This is going to be 9/2 theta. The integral of this. Are we all right on that?
Yep.
Okay. This, because of the chain rule, I'm going to need a 2 here. I'm going to multiply this by 1/2, and that's going to become 1/4. So that's going to become minus 9/4 the sine of 2 theta. All right. So if I take the derivative of this, let me just check. The sine would go to cosine, and then I'd have to multiply by 2 the chain, and that 9 would become 9/2. So here's the 9, here's the half, and that would become the cosine of 2 theta. Yes, ma'am.
Where, that's squared behind the 2?
Oh, no, I see what you're saying. I'll make it nicer. It looked like this. You understand there's a 9 here, correct?
Yeah.
And there's a half here, so I can write 9/2. That's this 9 and this half. And so then I have the cosine of 2 theta d theta. The chain rule says there needs to be a 2 there, and I think that's what you're thinking as a squared.
Yeah.
So that means I got to have that extra half. Okay, so now this becomes plus 9/2 theta minus 9/4 the sine of 2 theta evaluated from pi over 4 to 5 pi over 4.
Can you scoot it over, please? Thank you.
Is that a little bit better or no? So I'm going to plug in pi over 4, and I get 125 pi over 4 plus the cosine of pi over 4, I believe, is a negative square root of 2 over 2. So I have 30 times negative square root of 2 over 2 plus 9 times 5 pi over 4 minus, if I put 5 pi over 4 in here, multiply it by 2, I get 5 pi over 2, and I believe that is 1, so I think I get 9/4. Minus, in parentheses, now what do I get when I put pi over 4 over here? Well, I get 100 pi over 4. I get plus 30 times the square root of 2 over 2. I get 9 pi this should be 9/2, sorry. 9/2 times pi over 4. Pardon?
The first one should be 25 pi. It should be, shouldn't it?
No, because I got 5 pi, and 5 times 25
Bottom,
Bottom,
it
yes.
should be, it shouldn't be 100.
should be 25. Thank you. I'm getting ahead of myself. And then here, if I put pi over 4, I get pi over 2. And again, I get a minus 9/4. So, what do I have here? 125 pi over 4 minus 15 square root of 2 plus 45 pi over 8 minus 9/4 minus 25 pi over 4 minus 15 square root of 2 plus 9 pi over 8. Excuse me, a minus 9 pi over 8 plus 9/4. This gives me 100 pi over 4. That gives me negative 30 square root of 2. This gives me plus 36 pi over 8. This is 25 pi minus 30 square root of 2. This is, I think, 9/2 pi. And I think I get 59/2 pi minus 30 square root of 2. I believe that's correct.
Would you be able to write it out a little bit?
What? I didn't hear you.
Would you be able to write it out again? So it's like, because I'm like not confused about what all these numbers. Just like the thing at the bottom.
This right here?
That's simplifying.
Yeah, it's simplified.
So, Mr. Kruger,
Yep.
even though we
Okay,
do it on
so
calculator, he
that's
wants to do it on,
Um,
then on the test.
On something like this, I'd probably have you do it on your calculator. Okay. There's one coming up that you'll see that it's a lot easier doing on your hand. And actually, you get a kind of a cooler result. I'll get to that in a bit. All right, this one, number 8, we're finding the area inside r equals 3 sine theta. This is r equals 3 sine theta right here. That's this. So inside that, and then this right here is outside. This graph right here is r equals 1 plus sine theta. So the part we're looking at is this part right here. And if you take a look at it, what I like about this drawing is it kind of shows you the sectors. So I'm just tracing them in there. Did I talk about how you figure out the area in between?
Yeah.
Okay, and so it's going to look like this. It's going to be 1/2, and I got to figure out these intersection points first. So I'm going to have 3 sine theta is equal to 1 plus sine theta, and we're going to get what here? 2 sine theta is equal to 1. Sine of theta is equal to 1/2. So theta is equal to pi over 6. And what else? 5 pi over 6. What do you suppose I'm going to integrate from, and why am I going to integrate it to there? Pi over 6 to what? Pi over 2, exactly. because I got symmetry, so I'm going to multiply that by 2.
Would it still work if you did the whole thing?
Yes.
Okay.
Yep. The reason I don't do that is because sometimes I forget to multiply by 1/2 when I'm done. And now I don't have to worry about that. And if you take a look, you're going to have 3, here's your outer one, 3 sine of theta squared minus 1 plus the sine of theta squared d theta. So I'm going to have you do this one on your calculator, but I'm going to get in simplest form first. And I'm going to have 9 squared theta minus sine squared theta minus 2 sine theta minus 1. And so on your calculator, what I want you to figure out is the area from pi over 6 to pi over 2 of 8 sine squared theta minus 2 sine theta minus 1 d theta.
Do we have to get into that form, or can we plug it in on the top version?
You could either way.
So our calculator should be on polar still?
No,
Function.
it does not have to be. You could just be on regular rectangular, okay, because it computes. You could just do 8 times the sine of x squared, or you can write it in this form and put this in y1 and this in y2. It does not need to be in polar. In fact, I don't know if it actually integrates in polar. I think you got to integrate in rectangular. Yes, ma'am.
So when you put it into the integral on this one, you do like the 2 functions minus each other. You know what I'm talking about?
Yep.
Why didn't you do that on the last one? Like you just put in 5 minus 3 sine.
Because the last
Oh.
one wasn't in
Okay. If you notice, I'm figuring out an area between 2 curves.
Yeah.
Okay. I'm not here.
Oh. So how do you know which one to pick?
It's dependent upon if I draw this from the pole and I'm able to go straight to my graph and that area is encompassed in that, I don't have a difference between
Oh, you're right.
my radius. Where here I do. Here I have this length, correct? Minus this length. So I got technically a hole.
Okay.
Is that kind of the
Yeah.
idea? Did you get pi? I think you get pi as an answer.
Wait, so
I got pi.
That's fine.
You got something different?
You go, so you put the.
You was wrong? Okay.
Is piano extra different?
Okay, so pi's our answer?
Yeah.
Okay.
He is like. Then you go back to like what
All right. This one is how you figure out arc length. And to figure out arc length, they'll always give you what the length that you're going to have. And so in this case, I'm going to integrate from 0 to pi. And they're also going to give you r, or r theta. And in this case, it's e to the theta power. And what else you're going to have to figure out is you're going to have to figure out what dr d theta is. So Sean, what do you think dr d theta is here?
E theta.
Pardon?
E theta.
E theta. It's wonderful. I like E. So what I'm going to do is I'm going to take and I'm going to put in E theta because that's R.
times it by 2.
And I'm going to square it.
Never mind.
And I'm going to put the derivative, which is the same thing. And I'm going to square it. And that's going to give me, what is E theta squared? E to the 2 theta.
can you move it over?
And I got 2 of them.
So I'm just
Pardon?
2e
2 to the
2
2 to the e 2 theta?
What?
Yeah.
2e to the 2 thing.
Okay, so I'm going to make a jump here. Do you see where I get square root of 2, 0 to pi of e to the theta d theta?
Yep.
You're okay with that jump?
Is this?
So I have the square root of 2e theta evaluated from 0 to pi. And I get square root of 2 e to the pi minus what? Square root of 2. And you're done. I like that problem a lot. So that would be one where I would have you not use your calculator. Again, the formula for arc length is you just square r, figure out its derivative, and square that. And it's the square root.
You just keep it like that. You don't have to go further.
Nope, you're done. The only places you're going to revolve is around the polar axis. And the polar axis is this axis right here, what we typically call the x-axis. And the y-axis is called the line of where theta is pi over 2. So those are your two choices of rotation. And that's this one, and that's that one. So again, this one was kind of a cool problem, I thought, to figure out the surface area. And so r theta is equal to 2 cosine theta. I'm going to need that. And torus r prime theta would be what? You want to touch his elbow? Okay. My next choice was, do you know where the nerve is that we call the funny bone?
Yeah.
Do you know how hard you have to hit it?
Really?
Yeah. Okay. Ever done that to a classmate? It was quite popular in 1976, 1975. So Doris, what's the derivative of this?
2 cosine theta.
Yeah, negative 2 sine theta.
I second.
So it's going to look like 2 pi. I'm going to integrate from 0 to pi over 2 because I'm given that. I have 2 cosine theta. That's my r theta. That's the part that goes in there. Times the cosine of theta, that's part of the formula, is equal to the square root of 2 cosine theta squared plus a negative 2 sine theta squared d theta.
Are those the only two like lines that they'll ask you to revolve around?
Pardon?
Like she's asking if they can revolve around different lines.
You're only going to have it revolve around either the pole axis, the x-axis, or pi over 2.
Like
That's all we're going to do in here. Okay? So, does anybody know what this is?
One.
You're close.
2.
It's
Square
2.
root. Oh, 2.
Because I'd factor out a 4. Does everybody see
Oh,
that?
yeah, I forgot.
And I get cosine squared plus sine squared. And the square root of 4 is 2.
What?
Okay.
This is going to become this.
Cosine squared plus sine squared plus
4 cosine squared theta plus 4 sine squared
Oh, I
theta.
thought you were. I get it. I thought you were just looking at the cosine squared. I get the whole thing.
Okay, so I'm going to get 2 for that. So I now have 8 pi, 0 to pi over 2 of cosine squared theta d theta. And all right, so then I'm going to have 8 pi. Taurus, since you're on a roll,
What do you want?
replace cosine squared theta for me.
1 minus cosine 2 squared. Sorry.
Oh, 1/2 minus 1/2 cosine 2 theta, right?
Correct. But it's plus, right?
Right.
Correct. So here I'm going to get, when I do the antiderivative of this, I'm going to get 4 pi theta. So when I integrate this, I'm going to need a 2, correct? So this will become a half, which means I'm going to have 1/4. Am I all right doing this in my head, or am I making too many jumps? I'm going to need a time, and I'm going to have to multiply it by 2 here. In other words, I'm integrating this. I have 8 pi times 1/2. I have 4 pi. And I have the cosine of 2 theta. I'm going to need a 2 there. So I'm going to have to divide it by 2. So this is going to be plus 2 pi sine of 2 theta, evaluated from 0 to pi over 2. So I took this 8 pi times this half, got 4 pi. I have the cosine of 2 pi. I need, because of the chain rule, a 2. So I divided it by 2, and that's where the 2 pi came from. The antiderivative of cosine is sine. So if I put pi over 2 into here, I'll have 2 pi squared. Plus, if I put pi over 2 into here, I'll have the sine of pi, correct? The sine of pi is what? 0. Now when I put 0 into here, I'll get 0. When I put 0 into here, I'll get 0. Pardon?
2 pi squared.
Because there's already a 1/2 of the cosine.
Okay. So my answer is 2 pi squared. Again, a kind of a cool number. Alrighty. Ryan, why don't you set me up here? What goes where?
R equals, integrate from 0 to pi.
You want me to put 2 pi out here too? You probably said, I didn't hear you. Okay, we're going around the polar axis this time.
So you do 1 plus cosine theta times sine theta.
Yep.
And then square root cosine theta squared theta.
Plus what?
Plus negative sine theta squared.
I'll square that, correct? Right? This one again turned out to be kind of a cool problem to do. I thought it was going to be really bad. I was going to say, hey, you got to use your calculator here, but it turned out actually kind of nice. So this becomes 1 plus 2 cosine theta plus cosine squared theta plus sine squared theta. What does this become?
Is it going to be 2 plus 2 cosine theta.
2 plus 2 cosine theta. Exactly. Now, see if you can follow where I got this. 2 square root of 2 pi from 0 to pi. 1 plus cosine theta to the 3/2 power sine of theta d theta. I factored out the 2. That's where the square root of 2 comes from. It's exactly the same as this, but to the 1/2 power. And since that's an exponent of 1, I added the exponents. Rachel, does that make sense? Oh, I did that? I made some jumps here. So now I can reverse the power rule. What's the derivative of cosine? Negative sine, correct? So I need a negative there. So I need a negative out here. And I have 1 plus the cosine of theta to the 5/2 power. So I need 2/5 here. And I got negative 2 square root of 2 right there.
What happens with square root of 2 pi?
And I have a pi. Thank you.
Wait, so why is it negative?
Because the derivative of cosine is negative, and it was a positive sign, so I had to make it negative. And so I had to multiply the outside by negative. Evaluated from 0 to pi. So if I plug pi in here, what do I get? The cosine of pi. Negative 1. So it becomes what? 0. Minus a negative 4 square root of 2 pi over 5. And if I put 0 in here, what does this become? 2, correct? 2 to the 5/2 power, correct? So 2 to the 5/2 power. So that gives me a positive what? Well, this is 2 to the 1/2 times 2 to the 5/2 is 2 to the 6/2, which is 2 to the 3rd, which is 8, and 4 times 8 is 32, so I get 32 pi over 5. I thought that was a cool number.
32 what?
32 pi over 5. Around 150 something. Oh no, that's not right. Probably 32 times pi must be 96 divided by 5 must be 22, 23 maybe.
20.1.
20.1 was quite off. Alrighty. So, quiz tomorrow? Would you like the quiz tomorrow? Thursday? Should we have the quiz Friday?
No.
We're gonna be gone.
Okay, we'll have the quiz tomorrow. Super.
But I'm not